Let us revisit the classification of signals. So, in classification of signals, so we have already seen one type of classification, which is the continuous time signals and discrete time signals. So, we have already seen what is continuous time signals and discrete time signals. So, the second classification that we are going to see is the deterministic and random signals. A deterministic signal is a signal where you can predict the value at various time intervals at various points of time, whereas a random signal is a signal where you cannot predict accurately. There is a lot of uncertainty. Random signal is random in nature, so you may not be able to predict the value of the signal at a given point in time. The deterministic signal is governed by an equation, whereas a random signal there is a lot of uncertainty. So it cannot be represented by a mathematical equation. For example, in the case of deterministic signal, we can say y of t is equal to sine 2t, and we can say at various points of time, say at t is equal to 0, I know the value is 0. At t is equal to say say 1.7 or some value. All that you have to do is you have to substitute in for t here, and you will be able to calculate what is the value of sine t at that particular point instant of time. Whereas in the case of random signal, it is not possible. So that is a fundamental difference between these two. Okay. So next classification that we are about to see is the periodic and non-periodic signals. Now periodic signal, aperiodic signal. Now what is meant by periodic? Periodic signal it repeats itself at after some time interval. For instance, let me draw a periodic signal, then probably it becomes easier to understand. So let us say I am having a signal of this nature. So it is 0 here, and again after some time. So here the same the same signal is getting repeated after some interval of time. Say let us say this is 1, and let us say this is 2, -1, -2, so on and so forth. So the time period is 1 year. So the time period here is 1 second. After every 1 second, we see the repetition of the signal that has occurred between -1 and sorry, the time period here is 2 seconds. Okay. So the time the sample that you are the time sample sorry the signal that you are able to see between a -1 and +1, the same signal is getting repeated, okay, between 1 and 2, or between -1 and -2, so on and so forth. So this is a signal of this nature is known as a periodic signal. So then aperiodic signal is one which does not have this time period. So say aperiodic signal may be something of this nature. So we can have something of this kind. Okay, so that we are having only one pulse here. So it is not having any time period. Okay, so such a signal is known as an aperiodic signal, or a signal of this nature. Maybe you can have a signal of this kind. So this is an exponential decay signal, and this is not having any time period. It is not repeating itself after some time period. So so a periodic signal is one which has a time period, and an aperiodic signal does not repeat itself after a certain period of time. And I have just represented the continuous time case. Maybe we can try to draw this for discrete time also. For discrete time, you can draw something like this. Say I have a sample here 1. Again I have same sample getting repeated. So at 0, what you are able to see at 0? The same thing, the same sample you are able to see at 3. Let us say you are having another maybe you have on the negative side also you have, so it is -1, -2, -3, 1, 2, 3, 4, so on and so on. So here the time period is 3. So that the time period is 3 samples. Okay. So after every 3 samples, the pattern repeats itself. So you are able to see a pattern which is happening between 0, 1 and 2. The same thing is happening at 3, 4 and 5. So here the time period of this signal is n is equal to 3 samples. Okay. So in the case of a continuous time signal, the time period can be a fraction number. It can be a fractional in nature. Okay. Fractional. Okay, it can be something like 1.2 or some fraction it can have. So 3 or pi by 2 seconds. So these are all see the time period is seconds here. Here in the case of this is in the case of continuous time. In the case of discrete time, the period is samples, and it cannot be fractions. Okay, so cannot be fraction. So here it is n. The period is n here. The time period in the case of continuous time is t. Cannot be a fraction. It has to be an integer. So this poses a very severe restriction on the discrete time case. So let us continue the discussion further. Let us take a signal. Let us say we are having a signal something of this nature. So it continues, and you can see that this is the time period. Now I can write an equation for this. Let us say this is x of t. So x of t and this, let me call it as t. Time axis is t. So x of t, I can write it as sine. Let the amplitude be a. So I can write it as a sine omega naught, omega t. Now this omega is called is the angular frequency, and it is the units for this is revs per second. Okay. For a periodic signal, there is a relation which connects omega and t. Both when omega and t are multiplied, they should be necessarily equal to 2 pi. Okay. So using this, we will be able to find out in our examples, while working out problems, we should be able to find out what is the time period given omega and given given omega, given the angular frequency, we should be able to find out what is the time period. Similarly, in the case of discrete time, in the case of discrete time also, time x of n plus n will be equal to x of n if it is periodic. If the sequence is periodic in nature. Okay. Let us try to elaborate further on this. Let us say we have a sequence which is sinusoidal in nature. Let us say it is sine omega n plus some phase. Now I have not included the phase in the case of continuous time signal. The phase also can be included, which I have done it in the discrete time case. So here omega is this here again it is angular frequency, but the units for this here is radians. In the continuous time case, we said it was radians per second. Here it is radians per sample. Okay, and the phase psi is radians. Okay, so it is the same in the case of continuous time also. Now there is a connection between if omega and n. Here omega is here and the n, that is the period. So when you multiply these two, it should be equal to 2 pi and m. M and n are integers. That is, n is the smallest positive integer for which the sequence is periodic. Okay, that is, we need to find out the smallest positive integer that satisfies this equation. Okay, the smallest possible value of n which satisfies this equation is the period for this sequence. Okay, so the n here is known as the period for the sequence, the above mentioned sequence. That is, x of n is equal to a times sine omega n plus I. So these two conditions we have to be in these two conditions, that is omega t is equal to 2 pi in the case of continuous time signal, and omega n into 2 pi m in the case of a discrete time sequence are two important equations that needs to be remembered. Okay. So elaborating further on this, n by m will be equal to 2 pi by omega. Now you should understand both n and m, both n are integers. So which means it's a rational number, it's a rational quantity. Okay, so we have to necessarily be this necessarily needs to be a rational quantity for the signal to be periodic. That is an important condition. Okay. Whereas this level of restriction is not there in the case of continuous time. Okay, continuous time, the period need not, the time period is not a fraction. Actually, it's not a, it can be a fraction in fact, but in this case, n cannot be a fraction. So these are some of the things that needs to be understood before we venture out to solve some of the problems. Okay, let us take some of few examples to understand these concepts. So first, let us take the examples in the case of continuous time case. Okay. Let there be a signal x of t is equal to e to the power of j phi t. So this is imaginary quantity. So you have an imaginary quantity. We know from this can be expanded. Okay, this way instead of, we can write it as, this is an Euler form. This is the another form of writing the Euler form. So here you can find, so the question here is, we need to find out the time period. So this is a complex exponential signal, and which is purely imaginary also. And the question is, we have to find the time period. Find the time period. So we know for continuous time, we know that for continuous time case, the following equation will have to be satisfied. 2 pi. That is, we know by examining this equation, we can see very well that omega is equal to 5 rads per second. radians per second. So t is equal to, in that case, t will be equal to 2 pi divided by 5. So this is your time period. Okay, so let us take the next case. Two, we have another case whereas we have this equation. This is the signal. X of t is equal to sine 50 pi t. So just we have to substitute omega into this equation. If you substitute omega into this equation, you end up getting t is equal to 2 divided by 50 seconds. Okay. The next one, let us take the next one, which is 20 cos 10 pi t plus 5 by 6. So now this is phase. So we should be bothered only about this. This is the amplitude, this is the omega, that is the angular frequency, and this one is the phase. So here the omega is equal to 10 pi. So 10 pi into t will be equal to 2 pi, which the answer is 2 by 10, which is 0.2 seconds. So these are some of the suppose if let us take another case. If the question is find the time period for the following signal 10 pi t ut. Now the signal, if you want to, we can sketch the signal. This is sine 10 times pi t. Okay, so I'm sketching the signal here. Okay, so this is sine. If I multiply this with u of t, this I have to multiply by u of t. When I do the multiplication, I end up getting a signal of this nature. Now this signal is not periodic. So for a periodic signal, this is not periodic, this is aperiodic. So no, we cannot find the time period for this. Okay, so there cannot be any time period for a aperiodic signal. Let us take another case. Fine. Let us say we are having a signal minus magnitude of t. So if I want to sketch this, now the meaning of this is x of t is negative t for t greater than or equal to 0, and it is e to the power of t for e to the power of t for t less than 0. So we are having a signal of this nature. This is again aperiodic. So aperiodic signal will not have any time period. We can take some more cases and see. Let us say we can take u of t minus half. Now if you try to sketch the signal, so this is u of t and this is negative half. If I add up these two, if I add up these two, I end up getting, so it is negative half and it is positive half here. So this signal is again aperiodic. Okay, so there is no time period. What about this signal? So let us say we have a signal x of t is equal to, let us say it is 2 times u of t plus 2 times sine 2t. So if you want to sketch sine 2 of t, is something like this. So this is 2 here, negative 2 here, the amplitude is 2. With this I have to add another signal, which is 2. If I added these two signals, we know it will be something like this. This we have already seen, in fact. Okay, so this is negative, positive, and then we have something like this. So this is purely aperiodic signal. So there is no time period for this. So let us take another example. Let us take a case where so I think we need to take on one a different type of problem here. So let let us try to find the time period for the signal. This is it is different from the examples that we have discussed so far. So this is cos 60 pi of t plus sine 50 pi of t. So there are two omegas here. There is one angular frequency, omega 1 is equal to 60 pi, and there is another angular frequency which is, so for this signal, the time period for this signal is going to be governed by this equation, and the time period for the second term, that is sine, is going to be governed by this equation. So omega 1 is equal to 60 pi, t1 is equal to 2 pi. Here it is 50 pi, t is equal to 2 pi. So t1 is equal to 30, 2 is equal to 1 by 25. Now we have to find the time period t, that is I want t, not t1 and t2. Now there is one expression or equation. It says that n times t2 will be equal to, both m and n are integers. Okay, it should be something like this, that is m by n should be equal to t2 by t1, and this should be a rational quantity. M by n, a rational quantity. So essentially these should be integers, m and n should be an integers. So we are actually substituting for t1 into this expression is equal to 1 by 25, 1 by 22 in n. So when I cross multiply, it will be m by n is equal to 6 by 5. So I can write it something like this. So m by 6 is equal to n by 5. That is, when m is equal to 6, when m is equal to 6 and n is equal to 5, these two equations will, this equation will match, or this equation will be satisfied. So the condition is when m is equal to 6 and n is equal to 5, this equation is satisfied. So if I substitute m6 by into 1 by 30 is equal to 5 by 1 by, it will be equal to so the answer to this is, so t is equal to 1 by 5 seconds. So this is your answer. Okay, so it is 1 by 5 seconds. Okay, so let us take the another example. so that we understand this concept better. Let us say we are having x of t is equal to cos